On this channel, we provide useful programming information with practical code examples. This time, we'll talk about SharedArrayBuffer in TypeScript. We will explain SharedArrayBuffer in TypeScript with practical examples. Enabling subtitles will make the code descriptions easier to understand. SharedArrayBuffer is a mechanism for sharing the same memory space between multiple threads, such as web workers. By combining it with atomics, you can manage data races and perform low-latency shared memory operations. When using SharedArrayBuffer in the browser, co-op and COEP headers are required to meet security requirements known as cross-origin isolation. In Node.js, shared memory can be handled relatively easily using worker_threads. SharedArrayBuffer is an object representing a fixed-length sequence of bytes, and you can read and write numbers via typed array and similar views. Simple read-write operations are not synchronized, so you use the atomics API to ensure atomic operations and use wait and notify mechanisms for coordination. In this example, the main thread creates a shared array buffer and passes it to a web worker, with both incrementing a shared counter. This demonstrates the minimal pattern: atomic addition with atomics.add and reading with atomics.load. This example shows how the main thread creates a shared array buffer and shares it with a worker for multi-threaded access. In this code, the main thread uses atomics.add to increment the value atomically. On the worker.ts side, the same shared array buffer can be accessed and manipulated. In this video, we are only checking that no compile errors occur. If you want to actually run the code, you need to do so in an appropriate environment such as within HTML or Node.js. This is an example where the worker receives the same shared buffer and periodically decrements or manipulates it. The worker also manipulates the same memory through int32 array, and updates are made without race conditions thanks to atomics. By using atomics wait and atomics notify, you can suspend threads until certain conditions are met, enabling event-driven synchronization within worker threads. In browsers, the safest approach is to use atomics wait inside a worker. The producer writes data and notifies the consumer using notify. The consumer waits with atomics wait, and resumes processing upon notification from the producer. In this pattern, the producer notifies the consumer via atomics notify, and the consumer waits efficiently using atomics wait. Atomics wait cannot be called on the main thread in browsers. To prevent the UI from freezing, atomics wait is restricted to use only within workers. In a Node.js environment, you can handle SharedArrayBuffer functionality using worker_threads. Below is a TypeScript sample for Node.js. The main thread creates the buffer and passes it to the worker. This example uses parent port and worker data from worker_threads on the worker side. In Node.js, there are no co-op or COEP restrictions like in browsers, so shared memory can be easily handled just by using worker_threads. When using TypeScript, pay attention to whether you are building with common JS or ESM settings. SharedArrayBuffer and atomics are included in the standard DOM and library type definitions, so you can use them directly in TypeScript. When exchanging messages with workers, it is safer to define interfaces and specify types clearly. Explicitly defining types makes post message and on message handling safer and enables type checking. SharedArrayBuffer is not always necessary, but it is highly effective in situations where the speed advantages of shared memory are required. Understanding the situations where it is effective leads to appropriate technology choices. It is suitable for low-latency processing that requires high-speed shared buffers and can be used for real-time audio, video processing or game physics. For simple data exchange or transferring large amounts of data, transferable ArrayBuffer, or post-message, may be easier to use than SharedArrayBuffer. To use SharedArrayBuffer in the browser, cross-origin isolation is required. Set co-op to same origin, allow pop-ups and COEP to require corp. SharedArrayBuffer will be disabled unless these requirements are met. Atomic operations, atomics, are fast, but frequent waiting and excessive synchronization can increase latency. The following points should be checked to handle shared memory safely and efficiently. Views like int32 array should be handled with proper byte alignment. Be clear about which indices of the same shared buffer are used by which processes, and maintain consistent conventions in your code. If you treat a shared array buffer like a normal array buffer, data races will occur. Writing to the same index from multiple threads without using atomics is dangerous. By making proper use of shared array buffer and atomics, you can achieve safe and fast shared memory operations even in TypeScript. Starting with simple synchronization patterns like counters or signals is easier to understand, and by thoroughly managing correct synchronization and indices, you can be effective even in low latency scenarios. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. If you enjoyed this video, please consider subscribing to the channel and giving it a thumbs up. Thank you for watching.